Number 15 on the practice test. An ellipse has foci at plus or minus 3, 0 and vertices at plus or minus 5, 0. Write an equation of the ellipse in standard form and find the lengths of the major and minor axes and graph the ellipse. So we have a lot of information we need to find right now. So again, let's looking at number 14 again. This is the standard equation right here. To get the standard equation, we need the h, the k, and we need a and b. Remember here, looking at the center is hk. So that's how we can find it. So if our vertices are at plus or minus 5, 0, let's go ahead and try to graph that. Let's see, the markings here are at minus 20 and plus 20. So we're going to go, it looks like it's every 2, so I'm going to have it right here. So I'm halfway in between there. So that's my vertices. My center will be halfway between the vertices. Well, it's halfway between minus 5 and plus 5. Halfway between minus 5 and plus 5 would be 0. So my center, again, my center is halfway between the vertices. In this case, my center would be 0, 0. And let's see what else information do we need. We need the A and we need the B. A will be the length of the major axis, and B will be the length of the minor axis. I'm sorry, that will be half of the length of the major axis and half of the length of the minor axis. Please look at your sheet, the parabola. So I'm looking at this sheet right here, the standard of equation of an ellipse. I'm looking at that sheet right there. And you can see what I'm looking at now. I'm looking at the length of the major axis is 2a, and the length of the minor axis is 2b. So it's going all the way across is 2a, and then going all the way up and down would be 2b. So right here, going all the way across from negative 5 to positive 5 would be 10. So half of that would be 5. So in this case, A is 5. Now how do we find B? Well, we got to use the information about the foci now. And the way we can do that again is we know that c squared equals a squared minus b squared. Oops. So again, our c is 3, our a is 5. So 3 squared equals 5 squared minus b squared. Zoom out a little bit. So we can solve for b now. 9 equals 25 minus b squared. Negative 16 equals negative b squared. So I just subtracted 25 from both sides there. Get rid of the negatives on both sides. 16 equals b squared. B equals plus or minus 4. So therefore, we know what b is now. It's going to be 4, or plus or minus 4 here. And therefore, now we can go back and look at the original equation, and we can put in all the information that we know here. So again, h, k is the center, which is 0, 0. We know a is 5, b is, let's just say 4. Oops, sorry about that. So okay, now we're going to use the standard equation now. So it would be x minus 0 squared over 5 squared plus y minus 0 squared over 4 squared equals 1. And we can obviously simplify all that. That would just be x squared over 25 plus y squared over 16 equals 1. Okay, a lot of information there. Again, you have to think about how you would use the foci there, plus or minus 3, and how you use the vertices. Okay, a couple other nuances that I need to discuss here that I didn't get in when I was doing the problem. How did I know that A was 5 here? Why wasn't it B? Well, what happens is the foci, again, this is similar to number 14. The foci is on the same axis as the vertices. So again, that's the axis. You can see that. Therefore, I know that my major axis is on the x-axis. That's my major axis. My major one will always be the A. That's A is 5. And the other thing you want to use is that if it says plus or minus 5, 0, we know that A is going to be 5 then. I don't need to know anything else. Right here, it was plus or minus 3, so I knew that C was 3. This time it's at plus or minus 5. A is 5. I could have used the information that we talked about. So there's a couple different ways we can do the problem there. So again, what we said here, we said that the length of the major axis is 2a. So you can find the distance if you want, all the way across. But what's easier is just looking, oh, look at that. It's just plus or minus 5, 0. In this case, a would be 5. That only works for a standard equation of an ellipse. That does not work when I have the standard equation of a translated ellipse. So you can only use that information when you have standard equation of an ellipse. When I know that the center is 0, 0. That's when you use the standard equation. Any questions, please post it on the bottom of the video, please.